3.2 is on degrees and radians. So a radian of a circle has a central angle that cuts off an arc that is equal to the length of the radius of the circle. So that is going to be 1 radian. So each of these yellow highlighted segments is equal to the length of this blue arc. And that is what a radian is. Radian measures if a central angle is theta in a circle of radius r, it's cut off by an arc length s, then the measure of theta in radians is given by s over r. So in this, s represents the arc length, r represents the radius, and theta represents the angle in radians. And RAD stands for radians. We're going to use this formula to find missing pieces. Like example 1, a central angle theta in a circle of radius 3 centimeters cuts off an arc length of 6 centimeters. What is the measure in radians of theta? So we know r is equal to 3 and s is equal to 6. That gives us enough information to figure out what theta equals. And this is going to end up giving us 2 radians. Another thing that we're going to be going over today is radians and degrees. So all the way around a circle is 360 degrees, which is also equal to 2 pi. So if you want to draw that on a diagram, you can add it to your notes, but we know going all the way around is 360 degrees. And that's equal to 2 pi. Going part of the way, or halfway, is 180 degrees, and that would be equal to just 1 pi. Now if we go a quarter of the way, we know that is 90 degrees, and that's equal to pi over 2. And if we go 3/4 of the way, that is 270 degrees, which will equal 3 pi over 2. And that makes sense because we went 1 pi over 2, 2 pi over 2, and then 3 pi over 2. So you kind of want to count the parts. When we're going in between them, radians and degrees, we're going to multiply by 180 over pi to get from radians to degrees. To get back to radians, we're just going to flip that fraction over and multiply by pi over 180. And when we're going to degrees, usually the pi is going to simplify and you won't have that anymore in your answer. So let's do some examples really quick. The first one, we're going from 45 degrees to radians. So we're going to multiply this by pi over 180. Oh, I wrote 40. That should be 45. So when you're multiplying these, you can simplify before you multiply, or you can do it after. But I know both of these are divisible by 45. And if we were to do that, 45 divided by 45 is 1. 180 divided by 45 is going to be equal to 4. Now that we've simplified, we would have 1 times pi, which is pi, and 1 times 4, and that would be 4. You want to leave these in exact answers when possible. So we're going to leave it in terms of pi. All right, moving on to our next one. This one we have 450 degrees, and again, we're going to be changing it to radians, so we're going to multiply by 180 over pi. Now, this one, I don't know off the top of my head what is going to go into both of them. They're for their greatest common factor. But I do know they both can be divided by 10 to get rid of those zeros. Now we have 45 and 18. Another number I know goes into both of them would be 9. And that would leave us with 5 pi over 2. And that would be our most simplified answer. So you just want to find those common factors, and you do need to simplify as far as possible. Now let's do some examples where we're going 2 degrees. So for this one, we have pi over 6, and now we're going to be multiplying by 180 degrees over pi. Now by doing this, these pi's are going to simplify with each other, so we no longer have them. And then if you have any common factors, in this case they're both divisible by 6, we're going to be left with 30 degrees. And if you prefer, you can simplify after. So if you did 180 over 6 and then simplified, you would still end up with the same answer. Whichever way you show your work, it is up to you. Our next example, we have 4 pi over 3, and we're multiplying it by 180 over pi. Again, those pi's are going to simplify with each other. And both 180 and 3 are divisible by 3. And if we take 180 divided by 3, we're going to end up with 60 on top. So that leaves us with 4 times 60, which will be 240 degrees. This chapter, again, you do get a calculator, so a lot of this you can do on your calculator if you're not comfortable with the mental math. All right. And before, you may be familiar with the unit circle, and you can sometimes use this to help you figure out what reference angles you have for a certain problem. So you can look back at this as you need. Now we're going to work on evaluating some values in radians. Our first example is we're looking for the sine of pi over 6. Now, our last section, we did reference angles. So our reference angle for this one in radians is going to be pi over 6. If we needed this in degrees, you could convert that if you wanted. Pi over 6 times 180 over pi. Those simplify. And we are left with 30 degrees. So our reference angle is either pi over 6 in radians or 30 degrees in degrees. Knowing that information, we have a special right triangle. So this would be 1, 2, and the square root of 3. Now to find the sine of pi over 6, this is going to be 1/2. And that will give us our final answer. Now looking at our next example. This one, we're going to take 4 times the sine of 7 pi over 6. So when we're looking at this, we know halfway across is pi, which would be the same thing as 6 pi over 6. So we need to go a little bit further because we're trying to get to 7 pi over 6. So we'll go down here for our angle, and we know that is a total of 7 pi over 6. If we're looking for just our reference angle, though, we're looking for how far we went past that 180 degree line, or our x-axis. And in this case, it was just pi over 6. So our reference angle, again, is going to be pi over 6, which we already found out was 30 degrees. Now we can use that to solve our expression. So we have 4 times the sine of 7 pi over 6, which is going to be equal to 4 times, and if we do our special right triangles, this one's going to be -1 because we went down, and negative square root of 3, 2. So our sign for this one will be -1/2. And our final answer would be -2. So you do want to look for those reference angles to help you fill in the special right triangles. Next, we're going to evaluate 4 times the sine of 2x plus pi when x equals pi over 6. To do this, you're first going to substitute this in and then solve for inside the parentheses. Then you can evaluate the trig function. So we have 4 times the sine of 2 times pi over 6 plus pi. And if we were to multiply 2 times pi over 6, you can see the 2 would simplify with the 6, and you would be left with a 3 on the bottom. So we'll have pi over 3 plus pi, which is the same thing as having 3 pi over 3. So we're going to do 4 times the sine of 4 pi over 3. Now that we know what reference or what the angle is, we can draw it and find our reference angle. So this would be pi over 3, 2 pi over 3, 3 pi over 3, because that would be 1 pi. So we need to just go one more, and that's where we'll get 4 pi over 3. Now to find what our reference angle, we're just going to take 4 pi over 3 minus 3 pi over 3, and we'll get our reference angle to be pi over 3. And if you want to, you can change that to degrees, and that might help. So we're going to take this times 180 over pi. The pi's will simplify, and both 3 and 180 are divisible by 3, and we would be left with 60 degrees. So that's our reference angle in radians and in degrees. This being pi over 3, we're going to have negative square root of 3, -1, and a hypotenuse of 2. With this information, we can now solve our problem. And we're going to have 4 times the sine of 4 pi over 3, which sine is opposite over hypotenuse, negative square root of 3 over 2. Remember, when you multiply fractions, you just multiply the tops together, not the top and the bottom. And if we were to simplify this one, we're just going to be left with -2 square roots of 3. So that is all the notes for this section. One thing that I want to point out to you, all of these formulas listed below are going to be given to you on the test. So far, the only one we've gone over is S equals R times theta. One thing that you need to know is theta has to be in radians for this to work. And this is the same equation that we went over earlier, where theta equals S over R. It's just rearranged to get S by itself. So that will be given to you on the test. You don't have to worry about having it memorized. If you have any questions on this section, just let me know and I'll get back to you. The homework assignment is listed